Hello students, we are concluding first chapter of limit, continuity and discontinuity by solving these problems. So in order to discuss the continuity at a point, we have to find left limit as well as right limit, and if left limit exists, right limit exists, both are equal to the value of the function at that point, the function set will be continuous at that point. If left limit exists, right limit exists, both are equal, and both are equal but not equal to the value of the function at that point, then the function set to be discontinuous at that point, and the discontinuity of this kind is called removal discontinuity. If the left limit exists and right limit exists, but both the limits are not equal, then the discontinuity or discontinuity existing discontinuity is called discontinuity of first kind. If either the first limit does not exist or the right limit does not, if the left limit does not exist or right limit does not exist, and the or either of the two limit does not exist, then the discontinuity of this kind is called discontinuity first second kind. So while now in this lecture we'll discuss continuity and different kind of discontinuities, and uh, if we want to make a function continuous at a point after removing the removal discontinuity, we'll discuss this thing. Now let's start with the first problem. Is the function fx is equal to n minus 1 if x is equal to 1 and is a natural number, and fx is equal to 1 minus x to n upon 1 minus x if x is not equal to 1, continuous at x is equal to 1. If discontinuous, then state the kind of discontinuity. So we'll discuss different kinds of discontinuity by solving these problems. So the solution to this problem is, now the domain of this function is all real numbers, and the doubtful point is x is equal to 1. So at x is equal to 1, we'll discuss the left limit as right limit, because now the function is same, so we can find only one limit that is from the right or from the left. So let's discuss the continuity at x is equal to limit x approaches to 1 of fx is equal to limit x approaches to 1 of 1 minus x is equal to n upon 1 minus x. Now we'll use this formula. X per a is per n minus x is per n is equal to a minus x into a is per n minus 1 x into x for 0 plus a is per n minus 2 x plus a is per n minus 3 x square and so on to a x per n minus 2 plus a naught is for 0 x per n minus 1. The general formula of it can be used a square minus x square, a cube minus x cube, a to 4 minus x to 4 and so on. This is general formula we are in natural. Now how many terms are there? How many terms are there? Now if we substitute a in this case is 1, a is for 1 is for n, x for n is equal to 1 minus x, a minus x into a is power n minus 1, 1 plus minus 1 into x equal 0, 1, this is equal to n minus 1, n minus 2, x and so on to is n minus 2, x square and so on to a is for a naught, x for n minus 1. So x minus 1 is cancelled out. Now this will be a polynomial function. Polynomial function, how many terms are they? From 1. If we replace, like now this is polynomial, the limit of x equals to 1 of a polynomial function is the value itself. Now replace x by 1. This is 1 plus 1, 1 plus 1 plus 1. How many times? 1 plus 1, 2, 1 to n minus 1. So n terms are they? N minus 1 plus 1, n times. So 1 plus 1 plus repeated n times, this will be equal to 1. So left limit is also 1, right limit is also equal to 1, and the value of the function at x to 1 is n minus 1. So limit exists at x is equal to 1, left limit is n, right limit is n, but the value of the function at that point is n minus 1. So If we replace the value of the function at the point of n by n, then this function become continuous. Otherwise, it is a, what kind of discontinuity this is? This is a removable discontinuity, and the function is have removable discontinuity at x equal to. Now let's next question. You examine the continuity of the function fx is equal to under root of 1 plus x minus under root of 1 minus x upon x if x is not equal to 0, and 1 upon 5 if x is equal to 0 at x equal to 0. So we want to discuss it. Now if we replace x by 0, 0, 1 minus 1, this is a 0 at 0 form. So now we'll find the, now again x, the function is same for left limit right limit. We'll find the only one limit x is 0 from positive or from negative. So I will be finding limit x is 0 from positive. So now the terms in the numerator are under root of 1 plus x minus x. So we rationalize it by changing sign of numerator. So we want to remove the terms of numerator. So we want to make it a rational function. So rationalizing it, so a minus b into a plus b is equal to a square minus b square. So this is equal to under root cancelled. This is 1 plus x upon minus 1 minus x. 1 plus 1 is 1 plus x minus 1 minus into plus 1 minus into minus plus. So this is 2x upon x and root of 1 plus x and root plus 1 minus x and root. X is cancelled. This is equal to 2 upon and root of 1 plus x plus 1 minus x. Now it's a rational function, and zero is also point of this domain. So directly this is not, this will if we replace x by 0, this will not become undefined. This function is defined at x equals 0. So directly we can substitute x equals 0. 0 will become 0.2 is 1. So left limit is 1, right limit is 1, but the value function at x is 0 is equal to 1 by 5. So can we make this continuous at x equal to 0? Yes. If we replace x, the value of function at 0 is equal to by 1, then this can be made as a continuous at x equals 0. But what kind of discontinuity is this? Left limit is 1, right limit is 1. The value of the function at 0 is equal to 1 by 5. So this is a this function is continuous at x equals 0 and have a removable discontinuity at x equal to 0. Now let's discuss another example. Examine the continuity of a function fx is equal to under root of 1 plus cos of 2x upon x for x not equal to 0 and 0 for x equal to 0. And again, we will find if the function is same for in the left of x, left of 0 and right of 0. And in case of discontinuity, state the kind of discontinuity. If this is discontinuous, so we'll discuss the limit and limit. Now again, this is function is x is 0. At x is not equal to 0, the function is this. So 1 minus cos 2x can be written as 2 cos square x by 2, 2 cos square x by x by x. This x is in and this is equal to, when x is equal to 0, this is equal to 0. This is x. And this is equal to under root of 2 and under root sine square under root of x is equal to modulus of x at x equal to x not equal to 0 and this is equal to 0. Now this modulus function is there, so we have to find both. Now if this function to be, for this function to be continuous at x is 0, we have to find the continuous limit x to 0 of fx must be equal to 0 f0, or because this modulus function, so we have to find the left limit as a right limit at x equal to 0 and must be equal to a value function. So we have to suppose that function. So let's find the left limit at x equal to 0. Limit x to 0 from negative fx is equal to limit x to 0 from negative and root 2x, this function root 2x modulus sin x upon x. Now change the limit from x to 0 to h. Put x is equal to 0 minus h as x is equal to 0, as x is 0 for negative, h is equal to 0 for positive, for positive. And sine of minus theta is equal to minus sin theta, and modulus of minus x is equal to x. Substitute value. So under root 2 is a constant, it's taken outside. Limit h to 0 of sine of minus h modulus upon 0 minus h, 0 minus h, sine of 0 minus h minus h. Sine of minus h is equal to sine of minus h minus sine h modulus of minus h equal to sine h upon h minus is common. Minus is there under 2. So limit h to 0 of sine h upon x equal to 1 is equal to minus. Similarly, right hand limit x equals to 0 from positive of fx equal to limit x equals 0 from positive of this root 2 sine x upon x. Again, substitution x is equal to 0 plus h, x is equal to 0 as x equals to 0 from positive, x equals to 0, always equal to 0 from positive. Now change that limit from x to h by make substitution. Make a substitution, then root 2 limit h to 0 of sine of 0 plus h upon 0 plus h, sine of 0 plus sine h, sine follow sine h is h upon h is equal to 1, sine root 2. Left limit is minus under root 2, right limit is under root 2. So first and second implies the function is discontinuous at x is equal to 0 and have discontinuity of first term. If left limit is this, right limit is both are not equal, then the function will have discontinuity of first kind at that point. Now let's discuss the continuity at x is 0 of the function f is equal to sine inverse of modulus x if x is not equal to 0 and x is equal to 0 if x is 0. So modulus x is equal to x if x is equal to 0 minus x is equal to 0. So again, modulus is involved in this function, so we have to find both elements. Limit x is 0 from negative fx is equal to limit x is 0 for sine inverse of modulus x. Now x is equal to 0 from negative, so again making such, so this will be equal to how much? 0 from negative. Sine of minus x is equal to minus sine x. Sine x will be x less than 0, which will be minus sine x. Sine of minus theta is equal to minus sine inverse of x. Sine inverse of x. Sine inverse of x. So put sine inverse of x is equal to t. If x is equal to sine t. So as x is 0 from negative, t equals 0 from negative. So this will be equal to t is 0 from negative t. Limit, yeah, this is equal to sine inverse. Sine inverse. So this will equal to t. Now make substitution as x is 0 from negative, t equals 0 from negative, t put t is equal to 0 plus h as t equals 0 from negative, h equals 0 from positive. So this is equal to minus limit h to 0 of 0 minus h is equal to minus plus h is equal to limit is 0. Now similarly, right limit x equals to 0 for positive f x equal to limit x equals to 0 for positive sine inverse of modulus x will be if x equals to 0, this will be x sine inverse x limit x equals 0. Now again put sine inverse x equal to t, again here put sine inverse of t. So similarly here sin is t, x equal to sine t, as x equals 0 from positive, t equals 0 from positive. So put t is equal to 1 plus 0 plus h as x is equal to 0, as t equals 0 from positive, t x is equal to 0, or h will be equal to 0, always from positive. So substitution here, replacement here, t equals 0, gain limit is 0. Left limit is 0, right limit is 0, and value function is 0. So this function is continuous at x equal to 0. Examine the continuity of the function fx is equal to x sine of 1 upon x minus 1 if x is not equal to 0, and 0 if x is 0 and x is equal to 0. If discontinuous, give the nature of discontinuity. Now, equation first is a given function x at is equal to gx equal to x, hx is equal to sine of 1 upon x, therefore fx become gx into hx minus 1 when x is not equal to 0. Now limit, again the limit x, whether we find the left limit right limit, both limit comes out to same because the function is same, so we'll find the limit to positive. Limit now this function limit x to 0 of gx is equal to 0, and hx is bounded for all real numbers, if there is a bounded in the neighborhood of x not x equals 0. So hx, because hx is bounded in the neighborhood of a point 0, using the theorem, limit x equals to a of gx is equal to 0. Hx is bounded in the direct neighborhood of a, therefore limit x is 0 of gx hx is equal to 0. So second and third, using this second third, we got uh, limit x is 0 of x into sine of an x equal to 0. So limit x is 0 of x into sine of n minus 1 is equal to limit x is 0 of x into sine of limit of 1. Limit of this equal to 0 to minus 1 to minus 1. And the value, but the value of f at 0 is equal to 0. So left limit is minus 1, right limit is minus 1, and the value function is 0. So this what kind of discontinuity is this? This is again a removable discontinuity. The function fx, this function have removable discontinuity at x is equal to 0. This is not continuous, and this is discontinuous and have removable discontinuity at x is equal to 0. Examine the quantitative function fx equal to this. This is polynomial function for x less than equal to 0. This is polynomial function for x equal to 0. So in such questions, if it is a polynomial function, we can in the left x less than equal to left put 2 here. The limit is 3. And right limit put 2 here. This is 3. 3 left limit is 3, right limit is 3, and the value function is also 3. So this function is polynomial function is quantity at x is equal to this is a polynomial. Second polynomial for x less than 0. For left limit is 3, right limit. Left limit is substitute the value because it is defined. It is not undefined. If it is undefined, then we have to process take a different path for solving the problem. Examine the quantity of the function defined by fx equal to modulus of x minus a upon x minus a if x is not equal to and this is 1 at this quantity x is 1. Again, this model function we have to find the left as well as right. So limit x is to a from negative fx is equal to limit x is to a from negative of f modulus x minus a upon x minus a. So put x equal to a minus h, x equal to 0 as x is to a from negative as equal to 0. So change the limit, and limit is equal to limit x to 0 of x a in place of a minus h into minus a cancel, a minus a cancel is equal to limit h to 0 of modulus of minus h upon minus h. Modulus of minus h is equal to h, minus sign is here, is equal to minus 1. Similarly, right limit will come out to be, in place this will be how much? This will be plus h, this will be plus h, we cancel, this will be h upon modulus h upon h, this is equal to modulus h is equal to h upon h, this sign plus, plus 1. So left limit is minus 1, right limit minus limit is, and this is plus here, and right limit is this plus, right limit is equal to 1, this is plus here plus, limit x is 0 from positive, from a positive is equal to right, left limit minus 1, right limit, both the limits are not equal. So this function is not continuous at x equal to x approaches a at x equal to a, and have first kind of discontinuity at x equal to continuity x. The limit of this limit doesn't exist, therefore discontinuous and have discontinuity first kind. Prove that the function fx is equal to x upon modulus x minus 2x. Again, modulus involved in the function fx, gx, hx. In any of the function, if the modulus involves, we have to find the both element, left and right limit both will be different here. And k for remains discontinuous at x0 regardless of the value of k. We can't make, means this function will not have a removable discontinuity at this, because we can't make it. We will have whatever value of k we put, this function can't be made continuous, it should be discontinuous. This means answer is there, means left limit and right limit both will be different. That's why this will not help us with converting into the discontinuity to continuous. So modulus is there, we will find definite. Limit x is to 0 from negative, fx is equal to limit x is 0 from negative of this function. So change the limit x to h, put x equal to 0 minus h is greater than 0 as x is to 0 from negative, h is equal to 0. Substitute here value, is equal to limit h 0 of 0 minus h, 0 minus modulus 2 into 0 minus h. So modulus of minus h is equal to h minus h upon h minus upon h plus 2h minus plus 2h. The h counter cancel out, limit will be equal to h cancel minus 1 by 3. So left to 1 by 3. Similarly, right limit at x equals 0, x is 0 from positive, limit is 0 from positive, this is equal to 0. Again, change the limit 0 plus h is equal to 0, h is 0 from positive, h is 0. Substitution, substitute the value, change the limit, limit h is 0 from positive, 0 plus h, 0 plus h modulus plus minus 2 0 plus h. So modulus of h is equal to h, this is equal to h upon modulus of h minus 2h, h upon h minus 2h is equal to h minus 1. So left limit is 1 minus 1 by 3 and right limit is minus 1. So both the limits are not equal. So this is a discontinuity and continuity of first kind. So discontinuity we can't, for whatever value of k may be, we can't remove this from the quantity because this unit is removed discontinuity. This is a this first kind. So discontinuity first kind can't be removed. Whatever value of k we may substitute in them. Let fx is equal to 1 if x is less than equal to 3, and ax will be if 3 is less than x is less than 5, 7 if x is less than 5. Determine the constants a and b so that the f may be continuous for all x. Now doubtful points are 3 and 5. So we have to uh, we have to suppose that the function contains 3 and 5. So we'll get two equations, and from these two equations, left limit at 2 is equal to left limit 3 is equal to right limit at 3 is equal to value function at 3. Left limit at 5 is equal to right limit 5 is equal to value function 5. We'll get two equations, we'll solve them. So doubtful points of continuity are 3 and 5, where the function has been split this split function. Our aim is to show that limit x is to 3 is equal to f3 and limit x is to 5 is equal to f5. That is, limit x to 3 is equal to f3 means limit x to 3 from negative fx is equal to limit x to 3 from positive. For positive of positive 3 is equal to 1. Limit of 3 is equal to how much is this? Is equal to 1 given. Limit x to 3 from 3 from positive is equal to ax plus b is equal to 3a plus b. Now f3 is equal to 1. So because the function is continuous for all x, therefore 3a plus b must be equal to 1 equation. Similarly for 4, left limit 5 is equal to limit x to 5 from negative. So the following function we can take the substitute value. There is no need to change the limit from 0 to h. We can change by changing you get the same value or directly substitute because these are following functions or constants. Is equal to 5a plus b. Similarly, limit x is to 5 positive 5 and f5 is equal to 7. So 5a plus b is equal to 7. We got the equation. From these two equations we can solve. They become simultaneous equation a and b. We can solve them for the values of a and b. A comes out to be 6 minus 10. It comes out to be 3, and substitute the value of 3 in any of the two equations, 6 or 10, we'll get b is equal to minus 8. So a is equal to a 3, b is equal to minus 8. The function becomes continuous for the whole of the domain for all set of real numbers, because this is constant. This is a constant function. They are polynomial functions: constant, and linear function. So constant function continuous everywhere. If we substitute a is equal to 3 and b is equal to minus 8, this function will become, this split function will become continuous. For what values of a and b will the following function be continuous for all x? Now again, same similar question. For x is less than 2 or equal to 2, function is fx is 13, but greater than 3, greater than 2, this is equal to ax square plus bx plus 1, and for x is greater than 2, this is equal to greater than 3, sorry, greater than 3 rather, this is equal to 17 minus ax. This is 3. Okay. Solution. Since fx is continuous for all x, therefore the function is continuous at 2 and 3. Since fx is continuous at 2, so left limit at 2 uh, and right limit at 2 must be equal to value function 2. Similarly, left limit at 3 is equal to right limit 3 is equal to value function 3. So Left limit at 2 is equal to 13, right limit 2 is equal to the following function 2 4a plus 2b plus 1. So 2 plus 1 similarly, and f2 is equal to 13. So from this equation we got equation 4a plus 2b plus 1 to 13. One equation is there, fourth equation. Similarly, since f is condition 3, so left limit at 3, right limit at 3 is equal to f3. So directly again, so f3 from negative. For this, we can make substitution or directly substitute the value is equal to 3, 9, 9a plus 3b plus c. One equation. But f3 for positive is equal to this is equal to 17 minus 3a. So left is right limit is equal to value function. Is equal to value function. So this is equal to we get another equation. Now equation 8 and equation this 5 are simultaneous equation. We can solve them for the value of a and p. A comes to minus 1 by 3 and b comes to be 120 by 3, and the function becomes continuous in the whole of the domain. Thank you very much.